lab students, Physics 208 students. We're going to start a new semester, so I'm one of your instructors. My name is Mrs. Call, and your other instructor is Dr. E, as you know from the lecture component, and our lab tech is Mark Sparlin. And together we're going to work on presenting a few online labs for you. We're looking at about 10 to 12 labs this semester, and these will be fully done online, and they'll have several components to them. Each lab will consist of a theory background part that you will do and review based on your lecture components of class, and we're trying to sync the labs with your class material so that you have a lot to draw on. You want to work out your theory part and then look at how you would verify some of this theory with experiment. So in the actual lab we have that theory background warm-up. Then we have a simulation component where a lot of our labs will be done via computer simulations. There's a lot of really good physics simulations out there. So some of the main ones are going to be dealing with motion and forces and energy, many different types of simulations. So we'll show you a few of those sample sets, and you'll get familiar with them in the very first lab, and then we'll sort of build on those throughout the semester. And then the other component, the second part to your lab, will be the do-it-yourself, the DIY part, where you could actually do a few simple experiments in mechanics at home. Mechanics, where we're looking at analyzing motion and forces and energy and work and momentum, has a lot of really good do-it-yourself experimentation you could do at home. So some of these experiments you could produce at home that sort of validate the theory component. So some of the things we'll have you do is like make a simple pendulum, like in this case, I just have a hexagonal nut on the end of the string, and I could change different lengths of string, change different mass bobs for a pendulum. I could time it with my iPhone or my iPad or smartphone, and I could figure out some certain elements in the motion of that simple pendulum and put those thoughts together and do an experiment. And analyze the experiment from that from that apparatus I put together. Another type of simple pendulum I could have is a ball on the end of the string. Okay, this should be very easy to produce. This is another type of simple pendulum I could produce at home, or even I could put a rock on the end of the string. So we will do a lot of experimentation with simple pendulums, but that's not all. We also will do, at the very beginning, I'll do a few experiments just with taking measurements, trying to figure out mass and length and knowing how to do our conversions, mass, length, and time. And then later on down the road, when we start looking at things like momentum, we could collide objects and try to see things like conservation of linear momentum at play, conservation of energy at play. So that's just a little sample set. So
So I just wanted to, hi, I'm Dr. E. For conservation of momentum, we have various objects which can run into each other, where one has an initial velocity and then a final velocity, and then we can show that these objects satisfy the principles of energy and momentum. We have a ballistic pendulum lab, where we can fire an object into a catcher's mitt. Some of the energy will be lost, but the momentum will always be conserved. And so this is a way of showing how collisions can be analyzed and made sense of using these basic principles of physics. Here we have a little Newton's cradle that also satisfies the principles of conservation of momentum and energy, and give us some results that we can verify with our basic equations. Here we have a guy who looks very talented, but in reality he is able to maintain his balance because his center of gravity is below the pivot point. And so this is an illustration of the principles of torque. Mrs. Call would also like to show you an amazing demonstration of pressure.
So, here we have a sealed vacuum and an open balloon at the top. So we take the stopper out, no longer a vacuum. So you can see the balloon deflate. So if I put air in this balloon, so I'm going to blow up this balloon, and it quickly deflates. But now, if I inflate the balloon and I seal it so that I create a vacuum inside, the balloon will not deflate. So the question is why? What's going on with the air pressure here and the differences? So this is a famous little demo. So we'll talk about air pressure later on this semester. And some other objects and experimentation we'll do is with circular motion and circular mechanics. We'll look at everything from orbits to spinning objects and conservation of angular momentum. This here is an Euler's top. E-U-L-E-R. That's how you pronounce his name, Euler. And so you could do a few different twists, and you could conserve. You look at conservation of energy and angular momentum with circular motion, in many of circular motion cases. That's only one of many types of objects that we could analyze in circular motion. Here's a rattleback, and this is an ellipsoid. The geometry is not entirely symmetrical. So as you see, as you spin this rattleback, it will mysteriously begin rotating in the opposite direction. The question is, I'll do this again because it's not behaving today. Just a slight spin. Let me do a longer spin. There we go, a little backwards rotation there. And here we have gyroscopes, which are wonderful tools at analyzing circular motion and circular mechanics, one of our big topics in this section of the course. So here we have a gyroscope, and you might have heard that name before, but what we could do is we could get this to spin. And there's some stability here in its spin, and as it slows down, you'll notice that it loses its energy in the meantime. So we'll look at a lot of labs involving spins and energy. And
you can also do that with a larger gyroscope, and you can see that these kinds of motions may seem unique to bicycle wheels and that sort of thing, but this is also critical to understanding the way that energy levels work in atoms.
Conservation of angular momentum. So the main topics we're going to hit, right, Dr. E, for this course and lab, your lab component will be in sync with your lecture component. We'll look at first measurements, all our standard measurements, and how we're going to measure things in our labs, and how we're going to do the statistical analysis. We'll look at motion, 1D motion, free fall, all objects fall, right? So you throw things up and mysteriously they come back down, right? We'll look at the objects changing the motion. I mean, the force is changing the motion a little later on, but first we want to analyze the motion 1D, 2D with our simulations and our do-it-ourself experiments. Then we'll look at forces, and we'll do a lot of force labs, and we start with, okay, what is the mechanism behind changing the motion of objects? So we're going to analyze a lot of different forces. So we'll start with gravity, and then we'll look at subsets of the electromagnetic force, like the normal force, frictional forces, right? So we'll look at some demonstrations in conservation of energy and work principles, and then linear momentum, as Dr. E showed you with the carts. It's something that we do use to study collisions a lot. And then we'll look at some aspects of fluid mechanics and pressure and heat. So I think that covers the most basic core principles for the class. So each one of these will have a lab where you do the theory, gather up your theory. You do some pre-lab questions to warm you up to the problem-solving skills involved in the lab. Then you start the lab, you do the simulations, and you relate it to your classwork, and we'll try to prepare you with we'll have some video supplements along with some other supplements for the lab to prepare you for that component. And then you'll answer the questions and do some data analysis. Some analysis may require you doing linear regressions and analysis, like make scatter plots, see if there's a linear relationship between the variables you're studying, like force and acceleration, right? So there is this linear relationship between those two vectors. So we can analyze those in a linear format. And then there's going to be some inverse relationships that you'll be looking at. There's also going to be some square relationships that are portrayed with the quadratic equations. So we'll give you a little tutorial in Excel. So see our Excel video on how to do some of this statistical analysis, and that becomes more and more essential with future physics classes. The more you do physics and engineering, the more statistical analysis, more mathematical analysis you're going to have to do with your experimental results. All right, I think we covered everything. Are you ready to go, Dr. E?
I'm ready.
All right, hang on. All right, I'm ready now. Theory at hand. So what we want to look at here is our labs will have a background theory review. So you want to be solid in your theory because that's what you want to test. And that theory will be experimented via simulations. There's a lot of wonderful simulations out there. We have a good collection for you. So simulations, we'll have simulated lab experiments on your computer you could do, and then some good DIY, do-it-yourself experimentation. So luckily for us, mechanics has a lot of simple experiments you could do and test theories out with simple objects. And we want to look at how to apply that theory and apply what we experiment with and come up with some other experiments we could do on our own. Okay, so you want to think it through. So the main ideas here is we want to experiment with motion physics, 1D and 2D, things like free fall and two-dimensional projectile motion. Okay, there's a lot of good experimentation we could do there. Look at the motion of falling objects and use some simple objects like balls, rocks, and of course we have feathers that we can use as well and compare those motions. Here's a feather. And then we could look at forces, look at how forces change the motion of objects. Some wonderful force experiments we could do. We could look at energy experiments and conservation of energy, which is one of our big principles we're going to be doing in physics. Then we'll look at momentum, linear and angular momentum, and some of the experimentation we could do there. Rotation, rotational dynamics, some experiments in simple harmonic motion, some experiments in fluid dynamics, a little bit of heat, and those are the core concepts in physics we'll experiment with. Okay. So the big idea is we don't always need fancy lab equipment to do. We'll do that when we can, but a lot of the do-it-yourself experimentation will involve putting apparatus together. So to make measurements, we'll be using protractors. We can use paper protractors, or we can use apps on our phone. Like this is a Measure Box app, and it has protractors and rulers on there. There's some apps that are calipers that we can use. And there's some other good apps for physics. So we'll try to stick to the ones that we could find on all smartphone versions. So some of the other things we could do here, not just construct a simple pendulum like this, but we could also construct cardboard circular patterns. We draw circles on cardboard, and we could look at the laws behind a conical pendulum. And we could also construct out of cardboard a physical pendulum and look at things like center of mass, center of gravity, time the motion, compare that to simple pendulums. Some other wonderful experimentation we could do at home or construct some equilibrium systems like this and look at the forces of work. measure those angles and find out what forces are acting on bodies. Okay, we'll do a lot of ramp designs. We could put ramps together and we could roll different objects down the ramp, like cans, different cylinders, different sorts of spheres, solid spheres, time them and look at the theory behind that motion and experiment with that. So there might be a little bit of a lab fee involved if you don't have these materials on hand. So you could expect to maybe spend $20, $25 on some simple apparatus pieces you could do. So these are some core objects that we'll use, and we'll be very specific in the labs. So as I said, most of your labs will involve that theory. We'll have this theory background that we'll explore on the first page, and then we'll do some problem solving with pre-lab, and these problems will be linked with the actual problems in the lab. And then you'll be doing some data collection for both your simulation and your do-it-yourself experiment. And when you do the data collection, you'll put that data together and analyze that data and come to a conclusion and solve some problems there. Okay, so these labs, these are all the labs for this semester. So there's a lot of fun stuff there and a lot of good experimentation. So we will see you in the next videos.